Well, hello and happy Wednesday. I hope that you are all having a great Wednesday. Of course, you all have your notes pulled out and open to section 9.4. Today we are going to be working with compositions of transformations. What that actually means is that we are doing nothing new today. All we're doing is two different transformations on the same thing. So in other words, compositions of transformations is a transformation is applied to a figure followed by another transformation. This means maybe I took a figure and decided to reflect it over the x-axis, and then I decided to translate it up 2 and down 4. You're just going to take that pre-image, make an image, and then make another image from the image. Of course, because mathematicians like to do crazy things and name random things, one of these orders actually has a name, and that is the glide. A glide is when you make a image translate, and then you follow it by a reflection. Now, this last word shouldn't look new to you guys anymore. Of course, it's on the back of all of your graphic organizers. Here's the thing. The definition that we wrote on it on Friday was an okay definition, and it covers the main idea of this. But the actual definition of isometry is a little longer. Isometry is the composition of two or more congruent transformations. Now, of course, the only transformations we know so far are congruent, so that means reflections, translations, or rotations. And of course, when you do two or more of those, you're going to have a result that is congruent to your original pre-image. Give you guys a second to finish copying all of that down. Here's the thing. When it comes to notation, we are still going to do our deal. If you can get all your notation right on the test, I will still add 1 point of whatever the score is on the test, extra credit. So say the test was out of 40 and you got a 38, congratulations, you actually got a 39 if you have all your notation right. That, of course, means that you need to know what your notation is for this. So let's talk about notation while we do an example. If we wanted to do example number 1, we know the order that we want to do our transformations by the order that it's written down. So if I start looking at my directions, the very first thing it says is after a translation along 0, 4. That means I'm going to want to translate my points first. Then we're going to follow that by a reflection in the y-axis. The rules for those haven't changed at all. They're still going to be the exact same. I like to do it by doing just one transformation at a time. So that means I'm going to find just this translation first. I'm going to take all of my points. I'm still going to call it, after it's translated, the primes. So I'll have K prime, L, how about J prime, K prime, and L prime. If I translated J by 0, 4, I'm going to add 0 onto my X's and 4's onto my Y's. So for J prime, I will have a 6 followed by a 3. For K prime, if we followed our rule, if I plugged it in here and said 10 plus 0 and negative 2 plus 4, you are all going to be like, yes, Miss Markle, we know this. It gives me 10 too. Thanks for showing your work, though, because work's important. Now for L prime, of course, I can do the same thing. 5 plus 0, well, that's still just a 5. And then if I did my negative 3 plus a 4, that's going to give me a positive 1. I know you guys know how to do this. That's why I only showed work for one. Of course, I would love if you showed work for all of them, because then I can actually pretend that I can read your minds. Here's where this new stuff comes in. I've already done the translation along 0, 4. So what I'm going to actually do is just cross that out. It's already done. I want to follow that by a reflection of the y-axis. That means my rule still applies. A new rule for the reflection on the y-axis or over the y-axis. You guys are all going to tell me what this is. I know you know it. Of course, you're telling me it's negative x, positive y. Here's where notation comes in big for this one. I already have a j prime. That means that I can't just make it j prime here, because I already have something called that. So we're not going to do anything fancy. We're just doing another transformation. So I'm going to pretend that it's a tally for the number of transformations I've done on the point, and I'm going to call it a j double prime. Now that I have that, I'm going to go up here. This j prime is now my new original quote-unquote point, which means I'm going to plug my j prime into my rule to get my j double prime. So that means I need a -6, +3. Wonderful. I bet that you guys can all do these. You're going to tell me that k double prime is actually going to be -10, +2. And don't forget about your L double prime, which of course is a -5, 1. Congratulations, you just did your first composition of transformations. However, you all want to graph it. I know, stop begging. It's okay, we can graph it. Of course, I'm going to scroll back up here a little bit so I can see those original points. If I was to graph all of these, I can go and graph my regular original figure. It would look something like this, with this being my L, K, and J. Hopefully yours looks a little bit neater on the paper than mine does up there. Just like before, we're going to graph both of our new images now. So I have a J prime. I still need to graph that. I can still go over 6 and up 3, which gives me my J prime, my K prime, and of course my L prime falls somewhere over here. Connect those. Ta-da! Fantastic. Now, before I used to only have to have 2 figures on my graph. With compositions, I'm going to need you to draw all 3. That means I still need my J double primes. So if I keep going, I've got my J double prime, my K double prime, and L double prime. I'm sorry about all the graphing. I know it's not necessarily your favorite part, but is it really that difficult to graph those points and connect the dots? Maybe throw some labels on there. Don't think I'm asking too much. Here's the thing. Because I'm not here to look at you all and know, yes, you know exactly what I'm talking about, or no, you have no idea. We're going to run through example 2 real quick. We'll just get all the new coordinates. So, of course, I can go here. And it says I need a reflection in the x-axis, as well as a rotation 90 degrees about the origin. How do we know which one to do first? Well, it says reflection first, so I'm going to do reflection first. Reflection for the x-axis, my new rule would be, you guys are so smart, x negative y. Yeah, sure. If we go ahead and plug that in for my C prime and D prime, we will, of course, get -7, -1 for C prime, and D prime will be a -3, -2. One down, one to go. Rotation 90 degrees. That means our new coordinates are going to be that's right, a -y, positive x. Because I already have a C prime, I'm going to call it C double prime. And that would leave us with a +1, -7. For D double prime, plug it into our rule, our image, and I would get a +2 and a -3. I know you guys are all going to be disappointed, but I'm not going to graph this one. Hopefully you graph it in your notes. If you want that extra practice, feel free to go ahead and do example number 3, but I'm going to leave you guys right here. I hope that this section is easy for you. Like I said, there's no new rules. It's just doing 2 of whatever we were doing before. And that will leave us with our homework, which is going to be on page 655. If you wanted to work on your graphic organizers, I think that that's a great plan as well. Maybe go back and see if you want to change that definition of isometry. Have a great afternoon.